Okay, good morning, everyone. Right, any questions while everybody join in? Please put them on chat as usual. Kiana. Okay. All right. Okay, so let's start doing those. 70, let me look at them. 75 and 77. Okay, so the main thing is the following. So if you have a curve and it's given parametrically, it means the x and y are given as a function of a parameter t, then the slope of the tangent is equal to the derivative of y with respect to t divided by the derivative of x with respect to t. So this is a point, that's the tangent line, and that's the slope is given by this formula. All right. Now with this, we're going to do number 75. So here we have the following: x equal cosine t plus t sine t, and the y is sine t minus t cosine t. And t equal pi over 4. Okay, so if we graph this, and believe me, the only way we can graph this if we use like decimals or some computer algebra system, there is no way out. We know how to graph this. And this is again example of a curve that we cannot even find an equation that relate x and y, because it's such a hard, it's very hard to basically eliminate t somehow and find something that relate x and y independent of t. So this is really a curve that really hard basically to even graph for us. So, but we want to find the equation for tangent line. So we use the formula. We need to find the slope at the given point, and then we find the point on the curve that correspond to t equal pi over 4, and we find our equation. So first, let's find the slope. It's dy dt over dx dt. Okay, so derivative of y with respect to t is, all right, that's the cosine of t minus, now I need the product rule here. It's cosine plus t times derivative of cosine is minus t. So it's going to be that divided by the derivative of x, derivative of cosine, it's minus sine, plus we need to apply the product rule. So it's sine t plus t times derivative of cosine, which is that. So finally, I will have cosine minus cosine cancel each other out, minus minus a plus. So I will have t sine t in the numerator, minus plus, I cancel each other out, and I will have t cosine t. So finally, I will have sine over the cosine, or if you want, tangent, not necessarily. Okay, so that's the formula for the slope at any time t. Now that's at any time, no, at specific time. So at a certain time t, at t equal pi over 4, the slope is, we plug in pi over 4 here, so we'll get tangent pi over 4, tangent pi over 4 is equal to 1. Okay, so we know that for t equal to pi over 4, the slope is 1. But now the question is, at this given time, where is the point? So now I'm gonna find after the point. Say, okay, for t equal pi over 4, where is the point? I need the x component and the y component. So the x component is cosine pi over 4. Oh, it's a nasty number, but that's okay. Plus pi over 4 times the sine of pi over 4. Okay, so we know that the cosine pi over 4 is square root of 2 over 2. So this would give me square root of 2 over 2 plus pi over 4, the square root of 2 over 2. Now what's the y? The y is the sine at pi over 4 minus pi over 4, the cosine of pi over 4, which will give me the square root of 2 over 2 minus pi over 4, the square root of 2 over 2. It means that at t equal pi over 4, my point is at those values. It means square root of 2 plus should be somewhere in here. That's the x. Now square root of 2 over 2 minus that should be somewhere in here. So that's the point. I don't know how the curve look like. I know that that's the point. The tangent is 1, so that's the tangent line. And my curve probably around this point is probably something like that. I don't know the exact shape, but I know that this is the tangent line to the curve. So the curve should either look like this, or could it look concave down. I don't know which one, but it doesn't really matter for us. So the slope here is 1. Now finally, I need to find the equation. I have the point. So I know that the numbers are really nasty, but the idea is simple. Equal 1, which is the slope, x, sorry, this is a minus in here, x minus square root of 2 over 2 plus pi over 4, the square root of 2 over 2. Okay, now I can simplify because I think we can simplify. I will have x minus plus minus. Okay, and then let's see how much I can simplify. This and this go away. So I will have x minus pi over 4 minus pi over 4 would leave me with pi over 2 square root of 2 over 2. Okay. So it's just the numbers are not messy, but the idea is the same. Okay, questions before I go
on? How did you graph a tangent line again?
It's just because the slope is 1.
Oh, so you just found one of the points and you already had the slope.
Right,
Okay.
but not one of the point. The point that corresponds for t equal pi over 4.
Okay, what was the point that you graphed it on?
I'm trying to understand the question. They want us to find everything at t equal pi over 4. Okay? So at t equal pi over 4, the question is, so you have to imagine that there is something which is moving. At t equal pi over 4, where is this object? Where is the x and y? So those equations gives me the x and the y. So at t equal pi over 4, I plugged in pi over 4 into the x formula, x equation to get that, and in the y equation to get this one. It means at the time t equal pi over 4, my object is somewhere in here.
Okay, I see. So you used whatever you got for x and y, and that's what you used for your x and y when you graphed the point?
Yes.
Okay.
Yeah, this is the square root of 2 over 2 plus pi over 4, which is this one. And that's the square root of 2 of 2 minus pi over 4 times that. That's the point.
Okay, yeah,
okay?
Thank you.
Yeah, and graphing this is nightmare. The only way I can graph it is just look it up. I don't know how to graph this function. This is a hard function to graph. So we just can Desmos graph it. Desmos, if you just look parametric equation and graph it, your calculator graph it. So I don't know exactly how the graph looks like, but the only thing I know that At t equal pi over 4, the graph of the curve is right there. That's what I know. And I know the slope is 1 because I computed it. So that's the slope. So how the curve look like? That's the tangent line and that's the point. So either it's going to look like that or it could look concave down. I actually don't know which one it is because I don't know the whole curve. So is it concave up or concave down? But that's intuitively what's happening. All right.
Okay.
I don't know any more than that. I don't know how the graph actually look like unless I graph it by using a system. Anybody else? Okay, so we look at number 77. 77, again, we have x equal 4 cosine t. Y equal 4 sine t. And the question is, find all points. So we need to find points where the slope is a half. Okay. All right. Now this curve, do we know how the graph of this one look like? On the side, not on the side. Do we know how the graph of this curve look like?
Isn't it going to be a circle?
That's absolutely a circle because it's a circle.
I just remember from yesterday. It was like x and y, cosine, sine.
Okay, who
but
can tell
I
us?
don't know the exact reason.
Okay, I'm gonna do it. I'm gonna do it. I want you all to watch why this is exactly a circle. X is 4 cosine. I'm gonna solve for cosine in this one. It's a trick you should know. I get x over 4. Please, I want you all to listen because I want you to know why this is a circle. This one, give me sine equal y over 4. You see what I did? I isolated the cosine and isolated the sine. Now I'm going to say, okay, for every moment in time, the cosine plus the sine, this is equal to 1. What does this mean? It means x over 4 square plus y over 4 square is equal to 1. It means that x squared over 16 plus y squared over 16 is equal to 1. I multiply by 16 across, I get x squared plus y squared equal 16. That's a circle centered at 0 with radius 4. Okay, so this doesn't have to do anything with the question that the problem is asking, but this is just for me to make sure that you know why this is giving me a circle. Because for every moment in time, regardless what t is, x squared plus y squared is equal to 16. It means that no matter what t is, x squared plus y squared equal to 16. It means the point has to be on the circle, radius 4. Because if you're on a circle, if you take any point in here, Pythagorean will tell me the x squared plus the y squared should be equal to the 4 squared, which is the 60. Okay, so that's why this is a circle. And I want all of you to absolutely know why this is a circle. All right, now I'm going back to the problem. On this circle, where are the points where the slope is a half? Okay, now by looking at it, I really don't know. I have to do the math. Okay, we say we're gonna set how we do those type of problems. We set the slope equal a half and we solve. So what do I mean? What's the slope? The slope is dy dt over dx dt. Okay, means the slope equal to dy dt is derivative of y, it's 4 minus 4 sine t, and the derivative of x is 4 cosine t. So it's going to give me minus tangent t. Okay, now I'm going to set minus tangent t equal a half and solve for t. So the question is, which t's will give me that? All right, let's see how to solve that. Tangent t equal a half, it means the tangent is minus a half. Okay, so what is t?
Inverse tangent of -1/2.
Exactly, it's inverse tangent of minus a half. Okay, and I'm gonna put something like that. So this is equal to what? Now, what's the inverse tangent of minus a half? I actually don't know. We have to pick up our calculator to figure that out. Now, let me go back to the graph. Let me go back to the graph. How many points do you think will have the same tangent on the circle?
2.
2. Because if you have there is a symmetry on the circle. There is a symmetry. Let us say I find one of them. Okay, the point has to be here because right here, the slope is negative. So if I want the point where the slope is positive, the point has to be down here. Okay, so somewhere here. But the symmetry of the circle tells me immediately there is another point that have the same slope. Which point? And then we'll do it algebraically why this is the case. Think about slope. Which other point on the circle will have, so let us say this is the slope of 1/2. Which other point on the circle will have the same slope?
100 degrees around.
I can't hear you because of the noise wasn't good.
180 degrees around the circle.
It means this point right there will have the same slope. Okay, just by the symmetry of the function, if this has slope 1/2, this will have also a slope of 1/2. That's really what the picture really tell me. Now, algebraically, it is the case. Let us see what's happening. So those 2 points will have the same slope. And now let's go back. What did we get here? We get t to be arctangent minus 1/2. That's correct. But now, how many angles have the same tangent? Remember that the tangent function is periodic. It means it repeats itself every pi. It repeats itself every pi. So every pi, it repeats itself. So that's the tangent graph. So I have the tangent to be minus 1/2. Let us say this one, minus 1/2. But then if I add pi to it, I will have another angle which have the same tangent. So tangent t is minus, another value is arctangent minus 1/2 plus pi. Both will have the same tangent because the tangent by itself is periodic, is period of pi. So it takes the same value every pi. So it takes the value arctangent minus 1/2 here, add pi, you have the same tangent. And now the question is simply, basically we're gonna evaluate those values, and because there is no nice angle whose tangent is minus 1/2, so we're gonna evaluate those, and okay. So I will have tangent inverse of minus 1/2. So I'm gonna have minus 0.4636, that's one value. And then I'm gonna add pi to it. And then I will get 2.6779. Okay, those are the angles. And the picture makes sense. So this is the negative t. So this is the t equal minus 4.636. And that's the other value of t. Okay. Now, I need the points on the circle. But the question is, find the points. To find the points on the circle, what am I supposed to do? So what I found now, for which value of t is the slope equal minus 1/2. How do I find the point on the circle where the slope is -1/2? Back to you.
We plug those values of t in for cosine t and the
Exactly, we plug in those values. So we're gonna have 2 points. The first one is the one that corresponds to that. The x would be 4 cosine of this number, which is going to be negative, and the y will be 4 the sine of this number. Okay, and then you evaluate the x and the y. Then we do the same. So we just plug in t for x and y in the equations. Then t equal 2.6779, and I'm going to do the same. I'm going to plug in the x, and you just plug it into your calculator and you get the numbers. 9, and then the y would be 4 sine that. And then I will get the 2 points on the circle where the slope is 1/2. Okay, please, questions before we move on. Questions?
Is a number always going to be that precise?
You mean
Like for
decimal?
Yeah.
It depends. Like in MATLAB, I don't know if they are asking you for how many decimal places. If you have to do it. Usually we pick like 3 decimal places.
All right.
Yeah.
Okay.
Okay. So what basically we're getting this point and we're getting that point. So the picture told me that we have 2 points because we know the graphing and we know that those points are basically symmetric. Actually, if I found one, what's going to happen once you find the x and y here, those almost you don't have to evaluate them in this particular problem. Once you know this x and y, the other one, they are basically the positive part. So if you get minus here, you're going to get the plus. So you don't even have to evaluate those. But this in this particular problem. In other problem, the points will be different. Right. Okay, now we're gonna, any more questions about the slope? So it's just mainly it's a formula that we can apply, but the part is that to remember that for the value of t, you have to plug in t into the equation to get the point. Now I look at number 40 and then we proceed. So number 40. Okay, find parametric equation. So we have a circle. -2, -3, radius 8, and generated clockwise. Okay, all right. Anybody found anything? Any ideas? Was anyone able to find anything?
Can you have x be 8 cosine x?
T. X
Okay.
equal 8 cosine x doesn't really make much sense.
Yeah, 8 cosine t, and then y be 8 sine t.
Okay, this will give you what?
It should give you the equation of a circle with radius 8.
Centered what? Centered where?
Centered at origin though.
Centered out. How can we make the center at -2, -3?
For the x equation, should it be -2 plus 8 cosine t?
-2. So
Yeah, -2.
we're gonna change it.
And same thing for y but with -3.
almost correct, not fully correct. Because, let's see, if I take this one, I want to show you how you're going to modify it. Modify it a little bit. If I take this, oh, no, sorry, this is correct, my mistake. I've been stupid. All right, why is this a circle? Why this is correct? Why this is a circle centered at -2, -3, radius 8? How can I convince you it is the case?
Plug in values for t.
No.
Because sine squared plus cosine squared equals 1. So you
Right.
can,
How can I use that?
you
How
can
can
solve,
what algebra I can do to use this property?
you can solve for the cosine and sine of t.
Exactly. I'm going to solve for the cosine of t, which is going to give me x plus 2 over 8. And I'm going to solve for the sine of t, which is y plus 3 over 8. And now I use the fact that the cosine square plus the sine square equal to 1, which will give me x plus 2 over 8 squared plus y plus 3 over 8 squared equal to 1. And now a little bit of math would tell me that this is going to give me x plus 2 squared plus y plus 3 squared equal 64. And that's a circle. And I'm going to go over that in the last section of this course to go back to the equation of a circle. That's a circle centered at -2, -3 with radius 8. So that will give me a circle centered at -2, -3 and the radius 8. Okay. So in general, what's happening if the center of a circle is at A, B, or HK if you want, and the radius is R. So that's the picture. Suppose the center is HK and the radius is equal to R, then the way the parameterization is H plus R cosine T, and that's the clockwise, and Y is K plus R sine T. That's always a parameterization of a circle centered at HK and with radius R. And in Calculus 3, you definitely will have to study this again because they are important ideas. But the last thing we're going to do in this section, and it's actually simple, is length of a curve.
I have a question real quick.
Oh yeah, sure, no hurry.
For the problem before where it says generated clockwise, how did you know it's clockwise or not?
Because if we, okay, I can draw it for that. I can draw it. So, I mean, I plug point as I was like we did yesterday. T equal to 0. So I will take a nice page and do it. So x is -2 plus 8 cosine t and y equal okay. And I know it's a circle, but I'm going to just plot enough point to tell me whether it's clockwise or not. So that's a t, that's the x, and that's the y. At t equal to 0, I am at -2 plus 8. That's going to give me a 6. And at the y will give me -3. Okay, so basically, I know my center. It's -2. That's the center. Okay. At t equal to 0, I am at 6 and -3. And I know that the radius is 8. So if this is 3, so the radius, we're going to go 5 right here. This is 2. So we know that this is my circle. That's really the picture here. Okay. So at t equal to 0, I am at, and this should be the 6 because the radius is 8. It's from here to here, I have a 2. From here to here, I have a 6. And this is minus 3. So this is what's happening at t equal to 0. I am right there. Now, if I take t equal pi over 2, I'm going to have a minus 2 in here because cosine pi over 2 is 0. And I will have sine pi over 2 is a 1, minus 3 plus 8, minus 3 plus 8, which is going to give me a 5. Okay, and I know that this is the 5 right here. So at t equal, we have minus 2 for the x. And so we're moving this way. Sorry, we need clockwise or counterclockwise? Where am I? Oh, that's generated counterclockwise. My apology. Okay, that's counterclockwise. How can we make it clockwise? Okay, so that's generated. What I gave you is generated counterclockwise. How do you think we can make it clockwise?
We could make the y negative or not negative.
We can make so we want one of them. We want the cosine basically to make it clockwise. What we want is as t changes, I want the object to go this way. All right, so it means I want the x to decrease and I want the y to decrease. So if I want it to go clockwise, it means I want the x, as time go by, I want the x to go down and I want the y to go down. So how can I take care of that? One way we can take care of it, we can put a negative in here. And I'm going to put a negative in here. That's what gives me the clockwise. And now let me check. At t equal to 0, I am at minus 2. And then I will have am I right? I think so. So at t equal to 0, I am at minus 2, minus 8. And at t equal to 0, I am at minus 3. So at t equal to 0, I seem to be going this way. I think I'm goofing a little bit around here. And at t equal pi over 2, where I am. All right. My mind went blank right now. Anybody can pitch in, and that shouldn't be hard. If I put minus cosine, I'm going to start right here because at t equal to 0, I am here minus 2, minus 8. It's going to put me right here. At t equal pi over 2, I am 6 is minus 2. And
Minus 3.
this is minus 3 here. Put me minus 3. Okay, let's do that. Let me do it. At t equal 0, I am at minus 10, right? And I am here at minus 3. At t equal pi over 2, I am at minus 2. And this I will be pi over 2 minus 3 minus 8. So, all right, so this is not working. So how can I fix that? All right, let me go to the regular circle. Before I go to this center, let me do it the easy way. Suppose I have circle centered at the origin. That's what we did yesterday, centered at the origin. And then I will fix the other one based on that. Centered at the origin and with radius 8. And suppose I'm going to go clockwise. This way. What's going to be the parametrization here? So oh, that was my mistake. Okay. The parametrization, my apology here, my mind went totally blank. All right. That's going to be plus here and minus here, and of the problem. Okay, all right. So sorry about the confusion. My mind went a little bit blank for a while. So it's going to be -2 plus the cosine and -3 minus sine. And let us see that this really absolutely makes sense. Sorry about the confusion. So this is x, this is t, x, and y. At x t equal to 0, I will be at, of course, -2. That's going to give me a 6. And this is going to give me a -3. So I am right here. At t equal pi over 2, I will be, x would be -3. And the y is going to be -3 plus 8, going to be here at t equal pi over 2 -3 minus 8, which is going to be give me at -11. And this is going to go that way. Okay. So to get it clockwise, the cosine will stay the same. It's the y which we're going to go take it down, go down. And that will give me the clockwise direction. Any other questions? Okay, so my mind went blank for a little bit because when I was changing them, I didn't pay attention that x is not really doing anything, because x is basically in both directions. It's the same value of x. It's the y which is going to go down. So I shouldn't have changed the x at all. I should only change the y. Right. So finally, length of a curve. Okay, so this is a simple formula that we learn and we apply. There is nothing really more into that. So length of a curve or arc length. Idea here is, let us say we have a curve and it's given parametrically. It means the x and y component are given in terms of a parameter t. So this is my curve. At t equal to a, we are right here. At t equal to b, we are right here. And that's the curve. So suppose C, curve given by x a function of t, y a function of t, and t between a and b. Okay. And also we're going to assume that C is traversed once. What do I mean by traversed once? What do I mean by traversed once?
Maybe it goes over the x line once, the x-axis,
Not, what do you mean go over the x-axis?
like the line itself, like it crosses the x-axis only once.
Not the x-axis.
Okay.
As you move around it, you move around it only once. You don't go twice around it.
Oh, okay.
Okay, so traversed once, it means you don't, like yesterday when we took the parameter for this, so the circle t between 0 and 4 pi, the effect will be we go around it 2 times. That's not what I want. I'm assuming that we go around it only once. We don't go around more than once. Then the length of the curve is given by. Okay, then the length of the curve C is given by the following integral. Integral from a to b of the square root of the derivative of x prime of t square, plus y prime of t square dt. Okay, so that's the length of the curve. So we're going to measure the curve. We get exactly this thing. So let us do one more example, an example along those lines, and then we move on. So example. So we're going to take x to be the problem we took a minute ago. For cosine t, y equal 4 sine t, and t between 0 and 2 pi. Okay. And we know that this is a circle. By now, we should know that this is a circle, which is the center is at 4. And I'm going to find the length of this circle. Now we know what the length is. We're just going to do it again using this formula, just to understand that this formula is giving me the length of the curve. So that's the length. So we'll go from here to here. That's really what we're going to find is the length of the circle or the circumference. All right, so let's apply the formula. What is the length? It's the equal integral from 0 to 2 pi of the square root of x prime. The derivative of x is minus 4 sine t squared. Okay, so first we should basically evaluate x prime here. So x prime is minus 4 sine t. Y prime is 4 cosine t. Okay, plus 4 cosine t squared dt. So this would be equal to the integral from 0 to 2 pi of the square root. Now 4 cosine t will give me 16 sine squared plus 16 cosine squared. Okay. So this will give me equal to integral from 0 to 2 pi. So it's just a matter of integration. There is nothing really deeper than that. We factor out the 16 here. I will have sine squared dt. Now finally, this is a 1 right here. So this is going to give me equal to. Remember, we're going to find the circumference of a circle of radius 4. So we basically know the answer. We're just doing it again. Integral from 0 to 2 pi of square root of 16, because this is 1, I will have 4 dt. So I integrate, it's 4t between 0 and 2 pi, means 4 times 2 pi minus 0, which is going to be equal to 8 pi. Now, is this correct? Let us remember, what's the circumference of the circle? The circumference is 2 pi times the radius, which is actually 8 pi. So that's exactly what we're doing. We're finding exactly the circumference of the circle, which is going to be equal to 8 pi. So I took an easy example just to tell you that that's exactly what we are in the process of doing. Now let me make a small note here about this idea of traversed ones. What's the idea here? Let us say I take the same curve. You don't have to write, but let me tell you the importance of traversed ones. Let us say I take the same thing, but I tell you t between 0 and 4 pi. Okay, I change the interval. What will be the effect? We're going to start here. The 2 pi will take me around the circle once. Between 2 pi and 4 pi, we're going to go around the circle twice. Okay, so if I take t between 0 and 4 pi, we're physically on the circle, but we go around it twice. Now, watch what the formula will be affected. Suppose I'm going to get 4 pi, and you don't have to write, but I'll tell you why traversed ones will be problematic. From 0 to 4 pi, from 0 to 4 pi, from 0 to 4 pi. Now, if I do that, basically, I'm going to get 16 pi, which is not the length of the circle. Okay, so the idea of being traversed ones is essential to have the exact length of the circle. So if I go around it from 0 to 4 pi, I do not get the length of the circle. Actually, I get it twice because I went around it twice. Because that's why we give the formula only when we traverse once, otherwise we don't get the exact length, because what we want is the length. It means if we take this and we measure it, what's the length of it? Any questions before we move on? Right. Today we're going to start section 12.2. Okay. Polar coordinate, and then we will do a little bit of calculus with polar coordinate. So today we do the basics, polar coordinate. Right. Okay, what's the idea here? So far, since you guys basically if you have a plane and we have a point in the plane, okay, then the way I can give you the position of this point so far, if I tell you where this point is, I tell you, okay, I give you the x coordinate and the y coordinate. Okay, that's how I tell you where the, so I tell you x is 2, y is 3, I tell you where the point is. xy are called Cartesian coordinate. Okay, x and y are called the Cartesian coordinate. Now, there is another way to tell you where a point is in the plane. Okay, there is another way I can tell you. What is this other way I can tell you where is point in the plane? So suppose we have, a plane, and I have a point. I'm going to locate this point, not by giving you x and y, by giving you the following. So this is a point P. Okay, and I'm going to call theta the angle between the positive x-axis or the horizontal axis and OP. So we're going to call OP, so P, point in the plane. P is a point. And we're going to call theta to be the angle between the positive x-axis, and that's important where it starts, the positive x-axis, and the line OP. That's my theta. And R, for now, for one more minute, is the distance from 0 to P. That's R, B, this one. Then the pair, R theta, is called the polar coordinate of the point P. So the pair R theta is called the polar. It's another way of specifying the point. So instead of giving you the x and y, we say, we can specify it differently. I can tell you how far is the point from the origin, and I can tell you the angle, and therefore I can give you the point. So it's a different way of saying where a point is in the plane. So let us see example. Sketch the following point with the given polar coordinate. Sketch the point with the given polar coordinate. Okay. So suppose I give you the following. 2 pi over 3. And those are, this is important, those are in polar coordinate. If they're in polar coordinate, it means this is the R and this is the theta right there. So we're going to sketch them. It's very easy. Okay. Pi over 3 is the angle. And we start from the positive axis, and that's crucial, pi over 3. Like 60 degrees, that's the angle, that's theta. And then this is the pi over 3. And then 2 units away. From here to here, 2 units. And that's the point P. That's the point. This is 2 pi over 3 in polar. I will put in parentheses polar because I want to emphasize that's polar coordinate, not Cartesian. The Cartesian are the x and the y that we will, tomorrow we'll talk the relationship between them. All right, let me draw 2 more points so we know exactly how to draw point when they are in polar. So suppose I give you the point 2. Let us say minus, I don't know, pi over 3. Okay, again, this is the R, and this is the theta. Theta is negative, and our theta is from the positive x-axis. That's where we start our theta, and that's important. So we're going to go down by pi over 3, and we're going to move away from here by 2. That's the point P with polar, this is 2 minus pi over 3, and in polar coordinate. Okay, so these are the polar coordinates. And my definition here, I'm assuming r is positive because I assumed r is the distance from 0 to p. So we can extend, we're going to extend the meaning of r to allow it to be negative. We extend the meaning of r to allow it to be negative. So we're going to allow r to be negative, to allow it to be negative as follows. Okay, so my r is positive. I take 1 extra minute, but we're going to allow it to take negative value in the following sense. The point r theta, actually I draw the picture, which is easier than, and then I will do the definition. Suppose this is r theta here. So this is my theta. And this is the r. This one is the positive r. Minus r theta will be the point, which is the reflection of r theta with respect to the origin. This point right there, this will be the point minus r theta. So it should be the reflection. So minus r theta is the reflection of r theta with respect to the origin. Okay, so that's the picture. This is r theta, this is minus r theta. So I'm going to sketch one point with negative r, and I will, of course, discuss this more tomorrow. So let us sketch the following point. Minus 1 pi over 3. And this is a point given in polar. So sketch minus 1 pi over 3. So what is minus 1 pi over 3? It's the point which is the reflection of 1 pi over 3 with respect to the origin. So minus 1 pi over 3 will be the following. First, I sketch the positive one. 1 pi over 3. Means this is pi over 3. I go on. I move one unit away. That's 1 pi over 3 in polar. Minus 1 will be the one symmetric to it. So that's the point minus 1 pi over 3. So we're going to allow, as I said, so this is the 1. Minus 1 pi over 3 is right there. So if r is positive, when r is positive, the point will be in the same quadrant as pi over 3, like here in the first quadrant. When r is negative, the point will be in the opposite quadrant of where pi over 3 is. So if pi over 3 here, minus 1 pi over 3 will be in the opposite quadrant. Okay. So just think about that a little bit, and tomorrow I will elaborate absolutely more. All right, any questions before I let you go?